Direct variation is a relationship between two things, usually variables or quantities, where if y varies directly as x, we can write an equation y equals some constant k times x. And some good examples of this are things like miles driven varies directly as the time on the road. And you know that this is true to be direct variation because of your distance, rate, time formula. Distance varies directly as time on the road. What is the constant of variation? The rate. Another example of direct variation, your quiz grade varies directly as the time you spend studying. The more that you study, the higher your quiz grade is. Let's try a few sample problems. Y varies directly as x, and if y is 9, when or x is 54, we want to find the constant of variation. So remember the formula y equals kx. Now what we know is that if y is 9, x has to be 54. Oops, 54. So what is k? I'm basically looking what times 54 is going to equal 9. Well, if I divide both sides by 54, I get 9 over 54, which reduces down to 1/6. So the constant of variation in this example is 1/6. I can use that then to find other points. So for this example, y varies directly as x, and y is 450 when x is 6. I want to figure out what is y when x is 10. So I'm going to start by finding the constant of variation. And I'm going to say, okay, y is 450 when x is 6. So I plug in x and y. Divide both sides by 6, and I'm going to get that k must be 75. That's my constant of variation. So the formula for this direct variation, 75 is y equals 75x. I want to know y when x is 10, so now I can plug 10 in for x. Y was going to equal 75 times 10, so y must be 7. There is another formula that relates two quantities with direct variation, and that involves a proportion formula. And usually we use this one when we're given ordered pairs that vary directly. So if I'm given an ordered pair, x1 and y1, and another ordered pair, x2, y2, I can create this proportion between them. Now it's very important what value goes where. So I have the first y value over the first x value, the second y value over the second x value. So if I look at this example, if this is what's given to us and we need to find y2, I'm going to plug it into the formula above. So y1 is 9 over x1, which is 15. y2 I don't know. I'm just going to leave it as y for right there, or y2 I guess. And x2 is 40. So then if I solve this proportion by cross multiplying, 15 times y2 is going to equal 9 times 40, which is 360. If I then divide by 15, y2 becomes, give me a second, 24. Oops, sorry. An employee's wages are directly proportional to the time worked. This is true because if I think about the number of hours I work and I multiply by my wage, my dollars per hour, I'm going to get my total wages, and that's directly proportional because k, the constant of variation, is how much I make per hour. If an employee earns $100 for 5 hours, how much will the employee earn in 18 hours? The easiest way to go about solving this problem is to write a proportion. So I'm going to take my first set of values, 105, and create a ratio. And that should equal the ratio of how many, or what the wages are for 18 hours. Notice wages are on top, hours are on the bottom. It needs to match up across the proportion. Cross multiply to solve. So 5W is going to equal 1800. W then is 360. So that means in 18 hours you can make $360.